43 October November 23. Okay, in first question we have density of oil and we have a density of water given, and we have to describe and explain final position of oil relative to water. Okay, so as the density of oil is less than the density of the water that is given, it will float. And why it floats? Because the density is lower than the density of water. In B part, we have to describe a method to measure the volume of irregular shape object. So irregular shape object volume is measured by displacement method that is explained as below. Okay. In second part, we have to find mass of the object. We have volume and density was given before. So using formula density equals to mass divided by volume, we have to rearrange it to make mass the subject, and putting the values we get this, and this is the final answer, 220 grams. Okay, in question number 2, this question is from the Hooke's law, and we have to write down the spring constant. As the Hooke's law states, F is equals to Kx, so K is equals to F divided by X. Okay, so F is, we have to look at the graph. This is the value of F, that is 14, and this is the value of X. So putting the values, 14 over 4, and that will give you 3.5 Newton per centimeter. And if you want to convert it into Newton meters, you have to multiply this with 100. Okay, because the centimeter is the denominator, so it will be multiplied when it go in the numerator. So answer will be 350 Newton per meter. So it is 350 Newton per meter, or you can write as 3.5 Newton per centimeter. Both are acceptable. In second part, we have to mark the limit of proportionality and label this point L. Okay, so limit of proportionality is a point where the straight line ends. If you see, this is the straight line, and this is the point where it is starting to curve upward. So this point is the limit of proportionality. In B part, shows a car traveling at constant speed around a corner at point A. This is corner A. This is the car. We have to mark with an arrow the direction of resultant force acting on the car as it travels around a corner. So as we know, whenever object is moving in a circular path, the direction of the resultant force will always be toward the center of the circle. So if you consider this path as a arc of a big circle, this is a possible circle and this is a possible center of the circle. So this is the direction of force. Okay. And the second part, what we have to do, corner B has a smaller radius. So we have to state what happened to the resultant force when it moved from this corner B. So resultant force is inversely proportional with the radius. So when the radius will decrease, the resultant force will increase. And third part, this question is from momentum topic. Okay, so what we have to find momentum of the ball. We have a mass and we have its velocity. Mass is in gram. You first of all have to convert it into kg. So divided by 1000, you get 0.19, and velocity is given 6.9. Units are perfect, meter per second. Use formula of momentum, you get this 1.3 kg meter per second. In second part, they are telling you after hitting the object, the ball bounces back. Okay, and along the same straight path of the speed with 1.5. Okay, keep in mind momentum is a vector quantity, so bounces back mean this term is indicating velocity will be taken as negative. Okay, because it's the opposite direction. So momentum is a vector quantity, so we have to accommodate this negative sign that is written here. Okay, let's minus 1.5. So using the formula conservation of momentum, momentum before colliding is equal to momentum after colliding. If you remember, the relation was m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Let's identify masses and volume and velocities. Okay, this was the first object, the ball. This is the second object. Okay, so this is m1 that you have to convert in kg. That will be 0.19 kg, and this is u1, initial velocity of the first ball. Second object, this is the second object. Okay, this was at rest initially, so as it was at rest, its mean u2 is 0, and mass of the second object is given here. This is m2. Okay, and this is bouncing back of the ball. So this is v1. You have to find v2. This is basically v2. Okay, so putting the values here, you get this equation, and simplifying it for this v, making it subject, you get this thing, and the final answer is 0.8 meter per second. Meter per second. Okay. In part C, the kinetic energy of the ball is 4.5 joules after the collision and 0.2 joule after the, and this is before colliding and this is after colliding, right? Calculate the change in total kinetic energy. You have to find change in total kinetic energy of the object during the colliding. So total kinetic energy means um, total kinetic energy before colliding minus total kinetic energy after colliding. Okay, that is how we can find the change. Okay, before colliding, the first ball, the first object was having this energy, and second object was at rest. So its kinetic energy will be 0. So this energy is the total energy before colliding. And after colliding, this is the kinetic energy of the first ball, first object that is given here, this. And for the object, second object, we have found the velocity here. By using that velocity, we have calculated its kinetic energy. That was the answer that we have to put here. So this total, this thing will give you final kinetic energy. So subtracting both of them, you get change in kinetic energy before and after. Okay, and question number 4. State the name of the lowest possible temperature, that is absolute zero temperature. And we have temperature in Kelvin, we have to convert in Celsius. So you have to keep in mind whenever you have to convert from Kelvin to Celsius, you have to subtract minus 273. And if you have to convert Celsius into Kelvin, then you have to add 273. Okay, so this is the answer. In part B, temperature of a fixed mass of gas at constant volume changes from 300 to 400 Kelvin. Temperature is changing, we have to tell about the pressure. So we know that pressure is directly proportional with the temperature, or temperature is proportional with the pressure. Okay, so increasing temperature will increase the pressure. So in explanation, we have to write down temperature. Basically, by increasing temperature, kinetic energy increase because temperature and kinetic energy are directly proportional. So when kinetic energy increase, the rate of colliding of the particle, collision of the particle with the wall will also increase. That increase the pressure, or we can say that they will exert larger force on the walls, so that will eventually increase the pressure. Okay. In C part, there is a pressure of 120, and what we have done, we have doubled the volume. So what is the pressure? So we know that pressure is inversely proportional with the volume. So if we double volume, pressure will be half. Okay, so it is 120 kilopascal divided by 2. This will give you 60 kilopascal, 60 K. Okay, this is one way. Or you can solve it by another way. That is, you know that P1 V1 is equals to P2 V2. Consider this as P1, and volume is V2 is 2 times of V1. It's double. So putting the value of P1 is 120 kilopascal. V1 that is equals to P2 into V2, put the values. So 120 kilopascal, V1 is equals to V2, and at V2 you can put 2V1. Okay, so keep this P2 on the right side and shift 2V1 on the other side. So P2 is equals to 120 kilopascal. Sorry, let me write it down clearly. It is P2 is equals to 120 kilopascal into V1 divided by 2V1. Okay, so this V1 will cancel V1, 2 ones are and 60, so P2 will be 60 kilopascal. Okay, you can do it by any of the way. Question 5. What we have to do in question 5, we have to scale diagram of wavefronts of red light approaching gap in the barrier. Draw 3 wavefronts after the wave has passed away. Okay, but we have to keep in mind these are the straight wavefronts after this is a diffraction phenomena basically. So after diffraction they will curve, right? And we have to keep in mind that the separation between the wavefronts before and after will remain same because there is no change in medium, so there will be no change in wavelength or the speed. Okay, so that will remain same. So what we are changing the light. Initially it was red light, now it is blue light, so we are decreasing the wavelength. It means the separation between the wavefronts will decrease from the previous one, so we have to draw them closer. In question 6, we have to sketch current voltage graph for a filament lamp. Okay, filament lamp is basically non-ohmic material. It does not obey Ohm law. Okay, so it's a curved line, and you have to keep in mind it always bend towards the voltage. Okay, and for explanation, basically as current increases, resistance also increase. So more velocity is required to allow electron to flow. So sorry, it's not velocity, it is more voltage. In B shows an electric circuit, calculate the reading on the voltmeter. Okay, basically this voltmeter is in parallel with the battery. This is the positive terminal attached to the voltmeter and this side is attached with this. So basically if you can calculate the voltage across this terminal, that will be the voltage on the voltmeter. So if you see this is the negative side, this is also negative side. The negative and negative are facing each other, so they will cancel each other. So we have to subtract them. 12 minus 3, that will be 9 volts. And second part, calculate the current in 4.2 ohm resistor. Okay, 4.2 is this one. So this is also parallel to it. So if there is 9 watts, if there is 9 watt, it means there is also 9 watts. We know the voltage, we know the resistance, we have to apply the Ohm's law. I is equals to V over R. Putting the values, you get answer 2.1 ampere. Okay, we have determined the current in 2.1 ohm resistor. 2.1 ohm, this one. Okay, for this we should know about the diodes. This is diode basically. If this is In the reversed bias connection, how if this is diode, if this side is attached with positive terminal and this side is attached with negative terminal, current will flow. This is forward biased. Okay, so current will flow. But if this side is attached with positive and this side is attached with negative, so no current will flow. This is reversed biased. Okay, so basically, if you see this is positive side, when the current move from there, it will flow, and from there it will flow. Okay, so there is zero current. Determine the reading on the ammeter. So for the ammeter is attached at this point, so it is calculating the total current as there is no current in this path. The total current will be equal to this current that was calculated earlier, that is 2.1 ampere. Okay, so calculate the electrical power transfer to the 4.2 ohm resistor. So you have to apply power relation P is equals to V into I. Voltage was 9, current is 2.1, it will give you 19 watt. In question number 7, shows the electric field pattern around point X. Draw an arrow to indicate the direction of force on the negative point charge placed at point Y. Okay. Negative charge always experience force opposite to the electric field. So if the electric field is, if this is the point, electric field will be in this direction. So the force will be in this direction. Okay. So electric field always apply force on negative charge in the opposite direction to itself, right? So what is at this point? We know that from positive charge, electric field lines always originate, and for negative charge, they move toward the charge. Okay. So this is positive charge. For B part, okay, you have to add it is a positive point charge. In part B, a piece of plastic is charged positively by friction. State what happen. State what charge transfer. So whenever there's a term transfer, it's mean positive charge transfer only in term of electron. Okay, protons will not transfer from one point to another because they are confined in the nucleus. So in electricity, only the particle that travel that is responsible for the transfer of charges is electron. Either it is a loss of electron or it's a gain of electron. So if it is positively charged, it means electrons are removed from the plastic, so it will be positively charged. Explain how the structure of electrical conductor differ from structure of electrical insulator. So there is, you have to draw the comparison. Conductors have delocalized or free electrons, while insulators don't have any free electrons. In question 8, we have to explain the direction of turning effect as seen by the observer at O. This is observer and turning effect current is going like this and from here like this. Okay. If you see if on this side, direction of current is in this direction, direction of magnetic field will be from right to left by applying left hand rule. Okay, you will calculate the force on the left side will be up, and is this side it will be down. Okay, so it will produce a clockwise movement. Okay, so in B part, the coil is replaced by otherwise identical new coil with 3 turns. Okay, so you have increased the turns, so it will increase the turning effect. Okay, if we, the third coil is identical to the coil except it has a more resistance. So if we increase the resistance, the current will decrease, right? So by when current decrease, the turning effect will decrease eventually. In part B, what we have a graph of voltage and time in which there are different times are given t1, t2, t3. Okay, if this is 1/4 of the cycle, this is complete one cycle, and if you compare this part and this part, they are same. This is 3/4 of the cycle. Okay, So initially it is at this point. So if I have to make a complete cycle, this is AB, this is starting point. After 1 by 4th, this will be, if it's clockwise, right? Clockwise, A will come at this point, B will come at this point. Then again at 1 by 2, this A will be down, B will be up, and again after 3 by 4, this A will come on left side, this will go on right side. Okay, so this is how you have to answer this. This is T1. T1 is basically 1 by 4. If you see from there, it's 1 by 4. So this will be the shape. And T2, T2 is basically complete cycle. So after one complete, this was 3 by 4, and after one complete cycle, the A will go again up and B will be at the bottom. So this is how it will. From where it started, it will end at this point. Okay, it's a complete cycle. And this is basically T3. T3 was, this is T3. T3 was 3 by 4. If you compare, both are same. So 3 by 4 is this thing. It's A on the left side and B on the right side. And question 9 is we have to, for each application of radioisotope, state and explain which type of radioactive emission is suitable and suggest an appropriate half-life for the isotope. For the smoke alarm, we use alpha because they have high ionization and their penetration ability is very low, so they can easily ionize the smoke particles. Highly ionizing and life cycle you can write between 10 years to 500 years. Right? Okay. You just have to estimate, suggest some appropriate half-life. No fixed value is required. For aluminium, we use beta particle because their absorption depends on the thickness of the beta. This is also you can write from 5 year or 10 year the half-life of the beta particle. Okay, so the next question they're asking you lead 20882 is stable. They're asking you why this with atomic number 214 is unstable. In 214 there are more number of neutron, so more number of neutron mean more mass, so it will be unstable, so it release the radiations. State two different sources of background, it's radon gas and building materials. There are many others that you can write. In question 10, we have to state what this H0 represents. It's Hubble constant, it's from the space physics portion. You have to write down the definition of formula for H0. H0 is equals to velocity divided by d. This velocity is the preceding velocity and d is the distance. Okay, now we have to tell the units of H0 is per second 1 over s. And in part 3 we have to estimate the age of the universe. Basically Hubble constant tells you about the age of the universe. If you take the reciprocal of this H0, this will give you time. And we have to state when cosmic microwave background radiation CMBR was formed and where it is detected. It was formed shortly after universe was formed. It's after the Big Bang, and it can be detected anywhere in space. Okay, so that was the last question. Thank you for watching. Hafiz.